but I'll just review it. Okay, so in this circuit, we have basically we have one current coming out of a current source, and then it splits up, and then it comes back together. And so KCL tells us that the currents coming into a node have to equal the currents coming out of a node. So at this node right here, we get that I1 plus I2 have to equal I3, because I1 and I2 are coming in, I3 is going out. IS is coming up to the top. This top, we can see it splits into three currents. It splits into I1, I2, and I4. So IS has to equal I1 plus I2 plus I4. And then you could either substitute from the first equation into the second equation, or you can look at this node at the bottom and see that you have I4 and I3 coming into that node, and IS coming out of that node, and so IS has to equal I3 plus I4. We're given that I1 equals 9 milliamps, so we have the current through this 4 kilo ohm resistor. Since we have the current through it and we have its resistance, we can find the voltage across it. So we would take 9 milliamps times 4 kilo ohms, and a milli times a kilo cancels each other out, and that gets us 36 volts. So the voltage across this resistor is 36 volts. But notice this 4 kilo ohm resistor and the 12 kilo ohm resistor are in parallel. So they have to have the same voltage across them. So it also has to be 36 volts. Well, now for I2, and so now we can actually answer part A. For I2, we can say V equals IR, or 36 volts equals I2 times 12 kilo ohms. So 36 volts divided by 12 kilo ohms will give me 3 milliamps. So 3 milliamps equals I2. So I2 is 3 milliamps. Well, now, based on the work we did earlier, so we have that I1 is 9 milliamps, and I2 is 3 milliamps. And then, if you look at this, this should seem correct to you, because the resistance in the right-hand branch is 3 times more than in the left-hand branch. We have 12 kilo ohms on the right-hand side and 4 kilo ohms on the left-hand side. Since the resistance is 3 times as much, the current should be 3 times less, or 1/3, and so we should have 1/3 the current through this branch as we do that branch, and we do. Okay, so now I3 has to equal the sum of I1 and I2, as we wrote right there. So for part B, I3 has to equal, I3 has to equal I1 plus I2, and I1 was 9 milliamps, and I2 was 12 milliamps. I don't remember getting that number. Oh, it's not 12. Where did I get 12 from? That's 12 kilo ohms. That's why I didn't remember it. It was 3 milliamps. 3 milliamps. And so I3 is 12 milliamps. Okay, and now we want the current I4. Okay, so now to get I4, there's different ways, lots of different ways to do it. But what I see is that, okay, this is just going to be some resistor simplification. So I've got, redraw this. And this was 4 kilo ohms, and this was 12 kilo ohms. Now keep in mind, we know the current going through both of these branches, so we know that. 4 kiloohms and 12 kiloohms are in parallel. So their equivalent resistance is product over sum, 4 times 12 over 4 plus 12. So that's 48 over 16, or 3 kiloohms. And that seems right because you should always have the equivalent resistance should be less than either one of the original resistances. So that seems good. So this is the same as this. So this is 3 kiloohms. And then in our original circuit, this was 3 kiloohms. And this was 6 kiloohms. Alright, well, 3 kiloohms and 3 kiloohms in series, you can just add those together, so that's 6 kiloohms and 6 kiloohms. Well, now if I'm looking at I4 right here, so I4 is there, and I3 is the current coming out here, I3 and I4 are parallel, and they have equivalent resistances. So since their resistors are the same, then the current is also going to be the same. So I can say that I4 has to be the same as I3. So I4 is, what was I3? I3 was 12 milliamps. So I4 is also 12 milliamps. Okay, so now we know that. So we have 12 milliamps here. And I3 was 12 milliamps. So I have 12 milliamps coming into the node from this direction, 12 milliamps coming into the node from this direction. Part D asks for the source current. Well, the source current is I3 plus I4. IS is I3 plus I4, or IS is 24 milliamps.
In this case, would I4 not have the same would it have the same voltage as I1 and I2?
It would not, because, and let me show you why. I don't know why I just changed my computer to where I can't write on it as well. Okay, so to have the same voltage, you have to have if the ends are connected with nothing in between them, then they're at the same voltage. So the tops of this resistor, if I call this R1 and R2 and R3 right here, the tops of those resistors are all at the same voltage. But if we look at the bottom of this resistor right here, that has some voltage that I don't think I computed, but some voltage right here. But then it drops further as the current goes through this resistor, and I have a different voltage there, so that's V1 and that's V2. So on the resistor on the right-hand branch, the top is at the same voltage as these are, so if we call that V, that's fine. But the bottom of R1 and R2 is at V1, but the bottom of R3 is at V2. So it is not in parallel with I1 and I2. So I1 and I2 are in parallel, but I1, I2, and I4 are not in parallel. Now, I can say that this whole middle branch, if I treat that all together as one thing, that branch is in parallel with this. So I can kind of say that I3, sort of, you don't really say, I mean, kind of. If I say that I3 equals I1 plus I2, then I could say it was in parallel. So I can say I1 plus I2, that is in parallel with I4. So does that make sense?
Yeah, that does. Okay, thank
Okay.
you.
Yeah. Okay. Other questions? All right. Let's see. Nothing in the chat. No. Okay. All right.